रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा.
Hello and welcome to all students. In this lecture we learn about scalar valued function, and in this lecture we discuss about the point limit of scalar valued function along path. In the previous lecture we have discussed these 2 points: definition of scalar valued function and limit of scalar valued function. Now in this lecture let us discuss about limit of scalar valued function along path. Okay, so we start. So limit of scalar valued function along path. Okay, in R, what we have seen in the set of real numbers, in case of real valued function, the limit of function f of x at a point a exists if and only if. So when it exists, we know that left hand limit of that function at point a exists, and the right hand limit of that function at point a exists. Not only this, both left hand limit and right hand limits must be equal. Okay, then and then the real limit of a real valued function f of x at a point a exists. Okay, then if we see geometrically, we have a real line, and suppose a is a point here, then when the x approaches to the point a towards the left hand side, we call it is the left hand limit. If we find the limit of a limit at point a when x approaches to a from the left hand side of a. Okay, so this is the one way to approach towards a, left hand side on the real line. Okay, so if that left hand side limit exists, again we find the limit of a function f of x when x approaches towards a from the right hand side of a. Okay, so see here, x approaching towards the right hand side of a. So there are 2 ways to approach towards a in case of real valued function. Okay, so in both the cases, when x approaches towards a from the left hand side of a, when x approaches towards a from the right hand side of a, in both the cases the limit must exist and both limits must be equal, means left hand limit and right hand limit both must be equal. Then and then we say that limit of that function at point a exists. Okay, that is the very important thing. So in this case we can say that the limit of a point a exists if the limit of a function f exists if x approaches towards a from the all direction. Here are only 2 directions. Here to approach towards a, we have only 2 ways: either approach from the left hand side or approach from the right hand side, and in both the cases limit must exist. Then and then limit must exist and that limit must be, and both the limits must be equal. Then and then we say that limit of that function at point a exists. Okay, so this is the case in the real valued function. Okay, now if we go in the higher dimension, okay, then see what happens. Then what about now scalar valued function? We have to talk about a scalar valued function. Okay, Previous was a real valued function. Now we have to talk about a scalar valued function. Now see here, in case of R2, now we are saying that it is a real valued function, but as domain is a subset of R2, we can say it is a scalar valued function. Okay. Now in case of R2 or in higher dimension, there are infinitely many ways or there are infinitely many paths to approach towards A. A is the point in R2. So see here, x-axis, y-axis, perpendicular, origin. Okay. So this is xy coordinate system, and suppose there is a point A. A is a point in R2, and this is R2 plane, and we focus about how many ways are there to approach towards A here. So there are infinitely many ways to approach towards A, or these ways we can say paths. So let us draw one path like this. See here, path. Okay, we can approach towards A from this direction, or we can approach towards A from this direction. Okay, so I have drawn one path. You can draw many paths. See here, second path. Second path is, see here, we can approach towards A from this path, or we can approach from this direction. Okay, no problem. Third path. See here, third path. We can approach towards A from this direction, or we can approach towards A from this direction. So similarly, we can draw how many paths? How many paths we can draw through point A? So how many, or we can say how many ways are there to approach towards A along the paths? So we can draw infinitely many paths. We can draw infinitely many paths through the point A. That's why we can approach towards point A along infinitely many paths. Okay, so that is the thing. Okay, now we write the remark here now. Okay, in case of R2 or in higher dimension, the limit of a function f of x exists at point A if and only if the limit of a function f of x exists along all paths passing through the point A. And second remark is, in case of R2 or in higher dimension, the limit of a function f of x does not exist. When that limit will does not exist at a point A if the limit of the function f of x does not exist along at least one path passing through the point A. So both are the very important. But second remark is important as far as our problems are concerned. So to show that the limit of a function does not exist at point A, just we have to show that there exists at least one path passing through that point along that path. If the limit of that function at that point does not exist, then we say that limit of that function at that point does not exist. Okay. Okay. So second remark is very important. Okay. Now, now show that. Let us take one problem. Show that limit of function f of x comma y does not exist at point 0, 0. So we have to remember this second remark. We try to find at least one path. Just find out one path which passes through that point, and along that point function, the limit of that function does not exist. That we have to show only. Okay. Show that the limit of function f of x comma y does not exist at point 0, 0, where f of x comma y is equal to x square minus y square divided by x square plus y square for all x comma y not equal to 0 comma 0, and it is equal to 0 otherwise. Okay, so that is our function. Now we write the answer. Consider the limit of function f of x comma y xy tends to 0 0 equal to limit xy tends to 0 0 of the function x square minus y square divided by x square plus y square. Okay, now taking limit along the path y equal to mx. So y equal to mx is a path, and what is that point? Point is 0 comma 0, means origin. So y equal to mx, we know that y equal to mx, this represents a straight line passing through origin. Okay, so y equal to mx is a straight line passing through origin, where m is the slope of the straight line. So all these things about the geometrical. If we see the geometry of this path, this path geometrically represents a straight line passing through origin with slope m. Okay, so okay, so anyhow that path passes through the origin, means passes through the point 0 0. Okay, so if I choose this path y equal to mx, m is a some constant, m is arbitrary number. If I change m, then line will be changed, or then path will be changed. Okay, so for different values of m, we will get a different paths. Okay, for different values of m, we can have a different paths passing through the point 0 0. Okay, so if I choose this path, then what will happen? So consider limit of f of x comma y xy tends to 0 0, it is equal to limit. So instead of y, wherever is y, I will put mx. Okay, x square minus mx square divided by x square plus mx square, x comma mx tends to 0 0. So finally we can say that x tends to 0. Okay, so this is the function, it involves only x. Now we say that only x tends to 0. So x square, take a common from the numerator and take a common from the denominator, x square will get cancelled, and what is left is 1 minus m square upon 1 plus m square as x tends to limit as x tends to 0. But m is a constant, that's why limit of constant is that constant thing as it is. So 1 minus m square divided by 1 plus m square as it is. So finally we say that the limit of that function is, thus what we have, the limit of that function f of x comma y as xy tends to 0 0 is 1 minus m square divided by 1 plus m square. Okay, and we see that if I change the value of m, then the value of the limit will get changed. Okay, so or we can say that for different values of m, we get the different values of limit. Okay, so this shows that the limit of function f of x comma y depends on m. Okay, and for different values of m, we get different paths passing through point 0 comma 0, and for these different paths we get different values of limit, and thus value of limit along different value thus value of limit along different paths through 0 0 is not same. Therefore, the limit of function f of x comma y at point 0 0 does not exist. Okay, so limit does not exist. That is our aim, and it is that we have shown here. Again, let us take the next question. Show that the limit of function f of x comma y does not exist at point 0 comma 0, where function is given f of x comma y equal to x square divided by x square plus y square minus x for x comma y not equal to 0. Okay, so let us write the solution of that problem. Example, let L be the limit of function f of x comma y at point 0 0. Okay, so as we have solved such a problem in previous example, in the same way we solve this problem. Okay, so let L be the limit of function f of x comma y at point 0 comma 0. Okay, so therefore L equal to limit of f of x comma y xy tends to 0 0. Okay, so it is equal to limit xy tends to 0 0. The value of this function is x square divided by x square plus y square minus x. So now let us choose path like this, y square plus x plus mx square. Then what will happen? So now geometrically what is the meaning of this path and what is that path? So it is not necessary to write the geometrical meaning of that path and all these things. Okay, just we consider the path which gives me a different. If I use this path, then so choose path like this. Okay, which passes through the point, given point, our point is 0 comma 0. So you can check the path passes through the point 0 comma 0. Okay, the coordinates of that coordinates of that point satisfies this equation. Therefore we can say therefore we can say the this path passes through the point 0 comma 0. Okay, just choose a path which passes through this point. Okay, so if I choose this path, y square equal to x plus mx square, so you can observe it is chosen from these two terms here. Y square is equal to means y square x and mx square. Okay, so that for our convenience we are chosen like this. If I choose like this, then see what will happen. Okay, then what we have is L equal to limit x tends to 0. Now everything will come in terms of x. That's why we are writing only x tends to 0. Limit x tends to 0 of x square divided by x square plus mx square minus x. So this x will get cancelled, plus x and minus x will get cancelled, and what is left on the next line is L equal to limit x tends to 0 of x square divided by x square plus mx square. So again take x square common from the numerator, or from the denominator. X square will get cancelled and it is equal to limit x tends to 0 1 upon 1 plus m, but m is constant as we have seen in the equation. In the path m is constant, that's why the limit of 1 upon 1 plus m is 1 upon 1 plus m, and thus finally this shows that the limit of function f of x comma y depends on m. So obviously it depends on m, and for different values of m we get different paths passing through point 0 0, and for these different paths we get different values of limit, and thus value of limit along different paths through 0 0 is not same. Therefore the limit of function f of x comma y at point 0 0 does not exist. Okay, so again see here the limit of the given function does not exist at point 0 0. Okay, that is our. Okay, now let us see some problems for the homework. Question says that show that the limit of following function f of x comma y does not exist as xy tends to 0 0. Means we have to show that the limit of function f of x comma y at 0 0 does not exist. So these are the two problems, and hint is given to you. For first problem, choose this path y square equal to mx, and for the second problem, choose path x minus y equal to mxy. Okay, so let us stop here.
रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा